AP Chem. Yeah, so these don't pertain to like any particular like part of chem, but they're just like some like general things. So yeah. So the first question is reading a barrette. I think this is something you should have covered in chem before. So do any of you know the answer?
And we'll sort of be doing it like this. We'll be like doing more question types today.
Yeah,
Um,
yeah. Today will be more question based, and we'll just like tell you like how to like solve these types of questions. These are also all from like recent exams. So like almost all of these are from like the 2019 and 2020 exams.
yeah, that's where I put them.
And yeah, they all I recommend all of you guys to like go to the like Chemology website and you can like find the solutions for these questions.
So type in the chat what you think this one is. This shouldn't be too difficult. Cherry, do you want me to go to the next slide?
Yeah, okay, so yeah. Okay, we can go to the next slide. So okay, so the answer is C for this question because well actually like go back to previous slides, like I can show them like on okay, so if you look at this um so if you like this right now, so how you're supposed to read this is you're supposed to like read the bottom of the curve. So so it would appear that the bottom of the curve is around 6.6, but because it gives you it gives you the lines for like tenths, you have to have like one more digit of estimation. So in that case, you have to estimate this as 6.63 because you have to have one extra digit of estimation, and that would be like what so this is the official solution. So a barrette is a precise volumetric piece of lab equipment which allows for the estimation for one more digit. Thus, we can allow for one more digit beyond the marked 6.6. Thus, 6.63 is the correct answer, or C. When reading numbers, the last digit is uncertain and can be estimated. Note that barrette reads top to bottom.
Yeah, so that's like one easy mistake is like to not notice that. But yeah, last digit is usually like an uncertainty type of thing. So that's why we know for certain it's at least 6.6. That's why we have another number here because that's the one that's uncertain. Okay. So for the next question, we're sort of gonna revisit something that we talked about like all the way at the beginning um, of the year, which was like descriptive chemistry. Um, and so this is something that is probably in your best interest to memorize at some point before the exam, or right before the exam is the easiest way. And that's just like for example, this is a pretty common one is what color these ions give off in a solution. And so I'm going to post here a link to a Quizlet that I sent out earlier in the year. But this is actually, if you guys are on a computer, I would probably open that up because we're going to need it for the next question. Um, and so it just tells you like the color that you can expect. You can also see here like metal oxides, for example. Um, it's kind of annoying to memorize, but it definitely will be useful for like at least one question probably. So knowing that and knowing the Quizlet that I put in the chat, see if you can answer this next question uh, by yourself or with the help of the Quizlet if you need it. So for this one, um, yeah, all you guys put A and you guys are correct. So that's pretty straightforward if you just see the Quizlet. Um, I don't know. Terry, do you have anything to add with these types of questions other than just memorize?
No, not really. Yeah, you just really you just have to memorize this. These questions with colors are actually pretty common on the exam. So yeah, so if you memorize the table, like these questions are gonna be really easy.
Yeah. Like there's always at least one, right? Like you can always count on at least one. Um, and so when you're dealing with sort of a difficult test, that can, guaranteeing one question, with just like maybe an hour of studying max, maybe, is pretty good.
Yeah, and then also the other thing is like chemistry Olympiad, like the margins for like who gets in versus like where like everyone scores mostly are is like very close. So like one or two questions like this that can be easily like answered if you like just memorize it are going to be like a pretty critical role if you like want to qualify.
Yeah. And people that pass are gonna have this memorized, to be honest. Um, yeah.
Yeah. So next we're going to talk about phase diagrams. This like this topic comes up pretty much every year on the Olympiad. And so what a phase diagram is, it's pressure versus temperature. And then at like different points on the phase diagram, you'll have a solid, liquid, or it will be a gas. And then so what happens is if you like pass a certain temperature at a given pressure, it will like turn between phases. So for example, like up here, it shows like solid to liquid. If it passes this like line at any pressure, given the temperature, it will melt. It will melt if it goes from right to left, and then from no, sorry, left to right, it will melt, and then from right to left, it will freeze. And then sublimation is something that is asked a lot. So that's basically when you go directly from a solid to a gas, and that, as you can see, it only occurs at like very low pressure. And then when you have very low pressure, a solid can directly turn into a gas without going through this liquid stage. And then you have vaporization, condensation, and deposition. And then and then also there's this critical point up here. So what happens at this critical point is when you go beyond here, the pressure and the temperature is so high that it becomes a supercritical fluid. And what that is, it's basically you can think of it as like plasma. It doesn't fit into any of the three like states. It's not solid, liquid, or gas. So yeah, that's the basics of the phase diagram. And then we will move on to yeah. So type in chat if you know the answer. Yeah. So I guess we can go to the next slide. Okay. So the answer is C because okay. First, we're gonna look at this first statement here, and then so it says UF6 sublimes at atmospheric pressure. And so if you look at atmospheric pressure, it's 1 atm. And so as you can see, if you like follow 1 atm along here, it goes directly from a solid to a gas without passing through the liquid phase. The first statement is true, and atmospheres only UF6 gas is present at equilibrium. And so if you look at about 80 and 1.5, it's at the red dot there, and then as you can see, it's like clearly within this like gas area. So gas would be the only thing present at equilibrium. So yeah, so both statements 1 and 2 are correct, and the answer is C. Yeah, we'll go on to the next question. This one is a bit harder. Yeah, I guess we can go to the answer now. So the answer is C. So why it is C is because if you look at where rhombic is located in the phase diagram, you notice that it's in an area of generally higher pressure and lower temperature. And what happens is that higher temperature compresses mass into a smaller volume, and then lower temperatures reduce volume. And so because density is inversely proportional to volume, rhombic sulfur is denser than monoclinic sulfur. So the answer is C here.
Yeah, and you guys are right. You could also eliminate the other ones and see that that C is the only one that makes sense. Okay. All right. So the next sort of niche topic that's not covered in AP Chem, but you'll see on the test is this idea of the unit cell. And so this has to do with like crystal lattices, which I don't know if you've talked about too much, but that has usually to do with like ionic compounds, for example. Um, and so it's sort of this idea that uh, we have a repeating pattern here. And so could we sort of come up with a cube-like thing here? We called it a cell that sort of repeats over and over, and then from that cell sort of figure out, okay, what are like the proportion, for example, like what are the proportions of the atoms or the elements that we find here? And so yeah, so this is usually in talking about a crystal. Um, and I think the next one is maybe it makes a little bit more sense. So hopefully you know that like atoms are generally spherical, right? Um, and so there are multiple ways sort of that inside a cell you can describe like an atom inside of it. And these pictures can get kind of weird to look at. But in essence, what is important is that we have here, for example, let me see if there's like a good picture here. Basically, you can have atoms in the center of this cell that we come up with to describe the lattice. You can either have it at the center, um, in the middle of one of the faces of the cube. So like right here, for example, this is it's like in the middle, or you can have it in the corner. Okay. And so if you actually look at it, you might notice that like if the atom is at the center, then 100% of the atom is contained within the cell. Okay, so we count it as just like one atom. But in comparison, if you have an atom here on the face of the cell, then it's split in half, and so only half of that atom is actually included in the cell. So we count it as sort of like one half of an atom. And then finally, if you have it in the corners, it's split up into eighths. So only 1/8 of this atom, for example, is actually contained within the cell. And same here, only 1/8 of that. So we count it as 1/8 of an atom. Okay. And so the way we're going to see these questions later, or right after this, is that you have sort of uh, a picture that looks like this with dots showing where atoms are, and you're supposed to try to predict, okay, how much total, like, how many total atoms are per unit cell? But it's not just as easy as counting the dots. You have to consider, okay, is it like 1/8 of an atom, 1/2 of an atom, or the whole atom? And so we'll see that here in this next question, and see if you can calculate it and type the answer in the chat. Does anyone else have an answer that they want to put? I'm going to go in like 10 seconds to the next slide. Okay, so you guys are both right. It is going to be B here. And so again, let's look here at the thing that I typed out right before that was that corner atoms count as 1/8. 1/8 of an atom. Atoms on the center of a face count as 1/2, and center ones are 1. So if we think about it, we have one center atom right here. So that's just 1. So let's keep that in mind. We have 1. Then we have 4 gray circles that say they are on the faces of the unit cell. And so they're on the face. That means they count as 1/2. So 4 times 1/2 is just 2. So we have 1 plus 2. We have 3 atoms so far. And then finally we have these 8 corner ones, and each one counts as 1/8. So we have 8 1/8. That's just 1 more. So 1 plus 2 plus 1, we get 4, which is B. Um, okay, so the next question is sort of similar. And see, knowing this previous question, see if you can answer this one.
For your question, in the chat, yeah, you can generally assume that a white circle that's not on the vertices, unless it like tells you specifically in the question, you can pretty much generally assume that it's likely in the center.
Yeah, in the previous question, that white circle was clearly not in the corner. And in the question text, it said that the gray dots represented things on the face um of the cell, so you could assume there that's going to be in the center. Yes, these diagrams are kind of weird to look at in the beginning. So you sort of have to try to imagine what it would look like in 3D. Okay, so you guys seem pretty sure about this one, and you're correct, it is B. So same idea from before. We have one center. We have 6 faces, so 6 divided by 2 is going to be 3. Um, and then we have 8 corner ones here. Uh, and so adding those all together, you get 1x, 1y, and 3z, and so that's why you get this. So hopefully you understand why this is useful, right? Is that you have, if we say this cell here represents basically this lattice structure that we have of this compound that has X, Y, and Z elements or Z atoms, and so you're given this cell and you're told, okay, uh, basically this repeats over and over. We can say that this is the same. This is the ratio basically of X, Y, Z atoms throughout the whole thing, uh, which is useful.
Okay, so the next concept we're going to talk about is quantum numbers. This is another question that like appears every single year on the chemistry Olympiad. And what quantum numbers are a way to describe an electron's position and like spin using these four different numbers. So if you look at the table on the bottom left, you have your principal quantum number, which determines the size and energy level. You have your angular momentum quantum number, which determines the 3D shape. Your magnetic quantum number, which determines your spatial orientation. And then the spin magnetic number, which determines the spin state of the electrons. And so the and so like the type of questions that they'll like the chemistry Olympiad will typically test you on quantum numbers is they'll give you a set of quantum numbers. So they'll say n equals something, L equals something, and ML equals something, and then ms equals something. So actually, the last quantum number, the spin magnetic number, you can like ignore that. That usually isn't something that really matters. But for the first three numbers, it like matters, and it'll ask you like what is sublevel designation. So is it like a one? Is it 1s? Is it 2s? Is it 2p? And so on. And so if you memorize this table, if you know which n, l, and ml's correspond to which sublevel, you'll you'll generally be able to answer these type of questions. And also, there's another thing in terms of quantum numbers. So there's nodes, which tells you which you have this orbital. You can have like orbital diagrams that they'll test you on the Olympiad, and they'll ask you. So, for example, if you look at the bond the orbital diagram here that has maybe you can like draw it out with like your highlighter. So like the plot that has like the line going.
This thing here?
Yeah. So that one. So if you look at that one, it'll typically ask you something like, okay, so like what sublevel is this orbital diagram? And then so how you determine what sublevel it is you look at this concept of total nodes. You can kind of ignore angular and radial nodes. I think that's something that's like more asked on like the National Olympiad. But total nodes tells you how many times this green line crosses the origin. So this particular plot is a 3S plot, and so if you look at this sublevel destination chart here, if you look 3S corresponds with the n equal to 3, and then if you calculate your total nodes, it'll be 3 minus 1 is your total node, so you have 2 total nodes, and if you look at this diagram, um, the line crosses the origin twice, so you know that this is a 3S plot. And then so in the next question, so I guess we can just go to question. So which set of quantum numbers cannot correspond to an electron in the ground state phase PD atom? It'd probably be a good idea to look at the periodic table to get an idea of where PD is.
Yeah. Do you want me to pull up P table?
Yeah, I guess you can pull up TTP table.
All right. It was What was the question again? All right. PD atom. Um, Dude, where even is
So
that?
PD 46. Look at 46.
uh, oh, there we go. All right. So that one right there, number
Yeah,
46.
think about like okay, think about what it is. It 3D? Is it 4D? Like what is PDN?
Sure, I'll go back to the question. Do you want me to show the chart maybe? Or actually, it's probably
Yeah,
better.
sure, probably sure. Oh, you actually might not even need a periodic table for this question, but I just realized you can. This question you probably don't need a periodic table. Just okay, just look at the chart and see like what is not possible from the chart.
Um, is there any way for me to like show both sides at the same time? It's kind of weird. Here, let's do this
Um,
impromptu right here. Okay, boom, there we go. All right, does anyone have any idea for this question? Because it's sort of difficult in the beginning when you first learn about this. Okay, so you guys are saying B. Terry, do you want me to show the answer?
um, yeah. Show the answer. So yeah, you guys are right. It's B because if you go back to the question, um, yeah, okay. So if you look at the question, B, you can just go down to choices and see that B is just obviously not possible because if you look at this chart, like three, you can't have an N of three and an L of three at the same time. So it's just not possible. So yeah, so uh, this particular type of question is just a lot easier if you just go down the options and just take a look at what is possible, what is not possible, and then like I said earlier, like the MS really doesn't matter as long as the MS is like 1/2 or negative 1/2. Um, you should just really disregard uh, the MS value.
Yeah.
Yeah. So I think another question on quantum numbers. Are we given these charts? No, you're not given these charts on the exam. If you want to know what you're given on the exam, you can go look. You can just go look at one of the past exams. It gives you exactly what you're given.
Yeah,
You're
it's not
basically just given the
much.
periodic table and 3 formulas.
Yeah,
Yeah, they're not
pretty
going to give you
much.
anything like this.
But with this chart, it's actually not as difficult as you might think it is, because notice, so the N here just represents the what is the principal level or something is the name, I think. Yeah, principal level, which
Yeah.
is just sort of like each ring you can think of, right? So it's going to correspond to each sort of row in your periodic table. And then thing to notice is this L here um, goes from 0 all the way to 1 minus whatever n is. So here, since we have n is equal to 1, it just goes to 0. But like all the way at 4, it goes 0 to 3, but it doesn't go to 4. And so that's what should trigger you to see this and be like, this doesn't sound right because L should not be equal to n. Then yeah, this sort of corresponds to the periodic table, I guess, or to the electron stuff. Um, that you're maybe more used to. But the ML here, or M sub L, is actually just tied to the L. It includes 0, um, and it goes all the way up to the highest L that you have, but it also includes the negative. So this is always like an odd number, as you can see. But so if you actually look, this just goes, for example, at n is equal to 4 and L is equal to 3, it just goes from negative 3 to 3. So it's not too difficult to memorize how to like you could write out this chart after knowing these rules by yourself. And then the M sub S thing is just 1/2 or negative 1/2, and that just has to do with the spin. Okay. Anything else, Terry, for this one?
No, yeah, I think you have a pretty good explanation. So
Let me fix this up for people
I think
looking
there's
at it
another
later.
question.
Okay.
Yeah, okay. So this was the the radial like wave function plot I was talking about earlier. So just think of your nodes in this question. How do you calculate total nodes and what nodes mean? And then you'll get it.
Memorize here the diagram, and I'll go back to this chart, and it might help you.
Oh well, yeah. I guess this chart just gave the exact same diagram. But yeah, it is, but it is 3s here because when you calculate nodes, you calculate as n equals 1, and for 3s, the principal quantum number n is going to be 3, and so 3 minus 1 is 2, and so you'll have 2. So the line will cross the origin twice, and so that's how you get 3s. So next, this is another kind of like memorization thing. This is the same with the colors we talked about earlier. This you just have to like memorize this. They're not going to give this to you on the exam or anything like that. Um, so yeah, but if you memorize this, like the questions about flame tests are really just straightforward. They're literally just ask you like what color is what, and I guess we can go to question.
Yeah, I'll put a link to a Quizlet I made back when I was studying for SAT chemistry, from the book. It doesn't have all of these, but it has like most of these though. Although SAT chemistry is no more. Rest in peace. So you can open up that Quizlet, and hopefully it will help you for this one. Yeah, it is gonna help you. Yeah, I think this question is pretty straightforward.
Yeah, I mean, this is really just straightforward. If you just look at the chart earlier, it's pretty obvious that it's C. K potassium just is violet in a
Mhm.
flame test. So
Yeah. So if you're good at memorizing
yeah,
stuff, or at least you don't mind it, this is a good way to get like at least 1 or 2 questions right 100% of the time.
yeah, I would say flame test, and then colors, and then solubility is probably the three biggest themes that you probably need to memorize for the Olympiad.
Hmm. Yeah.
Yeah, I think yeah we can go on.
Okay, and I think this is the last topic of sort of like miscellaneous stuff that isn't in AP chemistry, but this has been in the past 2 years at least. I haven't even looked back, but know that for the last 2 years it's been. And so this is called the rate of diffusion, and this has to do with gases. And basically, you can see this picture up here gives a sort of a good demonstration of what we're talking about. Is you have these sort of two chambers here, and one of them has a gas in it, and then in the middle of those two chambers you have this little hole that allows just like a little amount of gas to pass through, or really just one molecule. And for some reason, I don't know, this is something that you need to know for the exam and that scientists care about, but it's the rate of diffusion. And so it's the rate of like how fast the gas sort of leaves through that hole and enters into the other chamber. And so in terms of absolute numbers, this is sort of difficult to calculate, or at least I don't think we have to know that. But you do have to know this formula here, which is how the rate compares if you had two gases in the same chamber, and you were to compare what is the ratio of their rate of diffusion. And so that's exactly what we have here. Is this? Imagine we have two gases here. If you were to take the rate of diffusion for the top gas, or for the gas number one, and then the gas number two at the bottom of this fraction here, uh, that ratio would equal the inverse square root of their masses. Yeah. So you can see here we take the square root of the mass of, and this is just the molecular mass of gas 2, over the square root of gas number 1. Um, and so keep this formula in mind because it's going to be needed for the next question. And also have a periodic table ready to calculate molecular masses for this one. Do you guys want me to go back to the formula or? Oh, here we go. Akshay, there we go. So I give like 30 more seconds or so. Um, which is, yeah, how much time again, Terry, is on the exam? On the local exam? It's like,
Uh, I believe it's 1 hour 30 minutes for the local. Oh wait, no, not 1 hour 30 minutes. It might be two. It might be like 1 hour 50 minutes or something like
yeah,
that for the
I think it
local
is. I
exam.
think it
I
is. It's
think.
like it's just under 2 hours, and there's what, 60 questions on the exam, or is it 50?
Yeah, 60
60.
60 questions. So you do get a good bit of time on the local exam.
Yeah. But just, keep in mind that you should try to be aiming to answer these questions in under 2 minutes for sure. Um, but also keep in mind that like it's easier here because you know what you have to do because we just sort of showed you. So that's just something to keep in mind. Is
Yeah,
like in the
and
actual test, you also have to figure out how do I even solve this question and then solve it. Um, yeah.
yeah, for like the actual test, like questions like these that we went over today, like honestly are questions that you should probably be able to get within like 30 seconds because you preferably need to leave time for the longer calculations ones, like the acids and bases
hmm
and the electrochemistry questions.
Yeah. So that it's good to review this stuff right before so that during the test you can instantly remember like, okay, yeah, like, oh, this is the formula for these type of infusion questions. Like I remember last time I forgot the formula for this, so it took me longer to do this question than it really need to. Okay, I'm gonna show you the answer. It doesn't seem like too many people gave a shot at it. So the answer here is actually D, and so you can see here the math that is done. So we're looking for a rate of fusion that is half of that of oxygen gas. Okay, and so here's the formula, right? And so this is from the solution set. They said that compound A was going to be oxygen, or compound one from that our earlier uh, equation. And with oxygen gas, make sure you realize that when it says oxygen gas, it's referring to O2, not just O. So oxygen by itself is, if you look at the periodic table, is 16. Um, but oxygen gas, that's 2. So that's why you get the 32. Then we want the rate of B to be half of rate of A, right? So we're looking for which gas is the fusion rate closest to half of that of oxygen gas. And so then it's just a matter of plugging that into here. Um, and then you get basically this formula right here. And so then if you square both sides and then you multiply the 32 to that side, you should get that MB is 128. And then it's just a matter of looking through the options here and seeing which one is closest to that. And xenon is 131, so that's the closest to 128. Okay, so just have that equation memorized, um, and hopefully it's easy from there. Yeah, yeah, actually, like that's the thing. One tiny mistake and it screws you up completely. Make sure you recognize that oxygen gas is always two. Usually when it's yeah, like whenever you see gas and it's like usually like a well, and then they have a gaseous element there. Uh, think of it in its natural state, which is usually two. Um, like nitrogen gas, for example. Okay, that's it for this meeting. We didn't have a final slide for this one. Um, yeah, I'm
Yeah.
just
So this
go ahead.
meeting we'll probably have like one more meeting midway through February, and then that would probably be our last before the Olympiad. But like I said, if any of you have like any questions or anything, um, you guys should just send us like a message on GroupMe, and then we can help you out with any questions you have. Like for this like last like month or two, like before the Olympiad, I just recommend you guys going through the past exams as much as possible. Like preferably like you should probably go through all of the past years. Some of the earlier ones are really easy, so you should be able to breeze through them. But and now they have solutions, so it's like pretty easy to like understand where you went wrong. But you should be like just grinding on practice sets right now. It's probably the best strategy.
Yeah, and if you want to learn more about some of these topics, pretty much all of these are found also in Zoomdoll. But if you can't find which chapter we're talking about, just like message one of us, and like at least I could tell you probably which chapter. So like for example, this is where I got the stuff about diffusion. Straight up, that's the diagram that I used. So if you want maybe a little bit more information and also practice questions that they include, those are found in Zoomdoll for sure. But yeah, if you have any other questions that you want to ask now, just leave them in the chat or you know unmute yourself, stuff like that. But other than that, thank you guys for coming and yeah, happy studying. Oh, and by the way, I'm also going to record this, or I have been recording this, and I'm going to upload it right now.